Chapter 5, Example 7. Suppose the normal model describes the fuel efficiency of cars currently registered in your state. The mean is 24 miles per gallon with a standard deviation of 6 miles per gallon. Sketch the normal model and write about it. So, again, this one tells us that the normal model describes it. We're not going to have to write that little sentence in this case. Our model is in 24 and 6. So this is very similar to our previous problem to start with. So we want to sketch the model. It's kind of ugly, but it works. So our mean is 24. Standard deviation is 6. So you get 18, 12, and 6 over there. These are miles per gallon. On the right hand side, let me fix this a little bit. I think that's a little bit better. We get 30, 36, 36 and 42. And this is state fuel economy. Now put in the empirical rule, 68%. 95%, 99.7%. Now we want to describe it because it's right about it. So, according to the normal model. We would expect, again, it's not, it will be this, a little bit of wiggle room. We would expect about 68% of cars to have fuel economies of between 18 and 30 miles per gallon. Approximately 95% of cars would be expected to have fuel economies between 12 and 36. miles per gallon. We always need that context there. And about 99.7% of cars to get between 6 and 42 miles per gallon. Yes, you need to write all that out, every word of it. That's how I would expect you to do it on a test. That's how you'll be expected to do it on the AP exam. What percent of cars get less than 15 miles per gallon? So now, we're going to use the z-score. We always want to sketch a picture. This isn't as detailed as above, but we sketch our normal curve. Okay, here's 24. We know one standard deviation is 18. So 15 is maybe right about, it's not quite 12, which we had there, so maybe about there. You just want the basic idea. A lot of this is for when we look in the tables, we know which way we need to go. Okay, so there's our quick sketch. So 15 minus 24 over 6, which is standard deviation. And we know this should be a negative number because we're shading to the left of the mean. This equals negative 1.5. So z is less than negative 1.5 is going to be 0.0668. We find that by looking in the table. We also use that in a previous example, so you might have that to refer to if you need. Now we want to write that up. According to the normal model, .7% of all registered cars are expected to get less than 15 miles per gallon. If you wanted to put about 6.7% of all registered cars, that's even a little bit more wiggle room there, safety, so that's good to go with too. What percent of all cars get between 20 and 30 miles per gallon? So this isn't really a formal way to write it out. I'm just kind of doing it there to illustrate. I'm going to draw a picture again. So 24, 18 is right there at the inflection point, so 20 is right about there. 30 is one standard deviation away, so that's a little further over there. So this is between. We need to find two values. We need to find a z-score for 20 miles per gallon and a z-score for 30 miles per gallon. So let's go ahead and do that. 20 minus 24 over 6 equals 2/3. So negative 0.67. Less than 30 is going to be 30 minus 24 over 6, which equals 1. Okay, negative 0.67 when we look in a table gives us 0.2514, and one standard deviation gives us that 0.8413. Now, remember this 0.2514 is this little chunk here on the left. The 0.8413 is everything on the left from the one standard deviation. So really we're just concerned about this area here. So we need to subtract, get rid of that little chunk. So this will be 0.8413 minus 0.2514, which gives us 0.5899. And now we're ready to write our answer up according to the normal model. According to the normal model, about 58.99% of all registered vehicles are expected to get between 20 and 30 miles per gallon. What percent of cars get more than 40 miles per gallon? So, start by sketching our picture. So our mean is still 24, one standard deviation, two standard deviations, 3 is 42, so it's right about there, very small amount, more than 40, so we're talking above the 40 mark this time. So we're shading to the right, not to the left. That's going to be very important. So, find our z-score. 40 minus 24 divided by 6 equals 2.67. So 40 miles per gallon is 2.67 standard deviations above the mean. Gives us an idea how unusual it is, which is fairly unusual. The closer you get to 3, the more unusual. The bigger that standard deviation is, the more unusual. And so now let's look up what that is. So this becomes, looking at our z-table, 0.9962. Okay, so we're saying that 99.62% of all cars get more than 40 miles per gallon? That doesn't make any sense. Keep in mind what the normal curve, what the z-scores tell us. The z-score always tells us the area to the left of a value. So over here on my picture, it's all this area that's in green. It's telling us all of that. The red is just the leftover portion. So we really want to take this away from 1. 100%, or 1, is the maximum amount. So to find the true proportion here, we need to do 1 minus 0.9962, which gives me 0.0038. So it's less than 1%. If you're shading to the right, of a data point, you're going to subtract from 1. Remember that. If you're shading to the left, you can use the number from the table. If you're shading to the right, you have to subtract the value from 1. So according to the normal model, about 0.38% of cars are expected to get more than 40 miles per gallon. Describe the fuel efficiency of the worst 20% of cars. As we've done on the previous examples, we need to sketch the curve. There's 24 miles per gallon. Now, 20 or 18 is one standard deviation away, which represents 16%. So 20% has to be a little bit before that. So roughly like there. And then we color in. This is 20%. We don't know what that z-score is. Okay, so we want to figure this out. We're going to use our z-score formula to do so. But first we need to find out what that 20% is. 20% is 0.2000, because our z-score in the middle where it shows the proportions is always 4 decimal places. So this gives us a z-score of negative 0.84. And we find that by getting as close as we can. I think this case, when you look at the table, you get negative 0.2005 is the closest you get to that value. So now we can set up our formula. 0.84 equals x minus the mean, which is 24, divided by the standard deviation, which was 6. And so we multiply by that 6. You get negative 5.04 equals x minus 24. We add that 24 to both sides, and 18.96 equals x. Okay, so far so good. Now we just have to write out this in the proper terms. So, according to the normal model, okay, according to the normal model, we would expect the worst 20% to get at most 18.96 miles per gallon. So according to the normal model, and I forgot to capitalize my N, that's a big no-no. Name of the model, always capitalize it. So we'd expect the least 20% of cars to get at most 18.96 miles per gallon. What gas mileage represents the third quartile? Well, again, sketch your graph. 24 miles per gallon is there, roughly. We'll try and make it a little more symmetric. Okay, that looks better. One standard deviation is there, which would give us 16%, so it's got to be before here. So 75% is roughly about there. We just want the basic idea. Okay, so 75% is the third quartile. 0.75 is 75%, which comes out to be negative 0.67. And just like the previous problem now, we write that out in our formula. So negative 0.67 equals x minus 24 over 6. We multiply by the 6, add 24, and when you do all this math, you get 28.02 equals x. By this point, we should be able to do that math pretty easily by ourselves, so I'm not going to show every step there. And now we just write it out. As you notice, these problems are actually starting to get a little bit quicker. So according to the normal model, the third quartile of the distribution of fuel economies is about 28.02 miles per gallon. And again, context. I have fuel economies listed in there because that's context, and I include the units. That all helps with the context. You need all of that stuff in your problems. It will be incorrect without context. There's no story there without it. Describe the gas mileage of the most efficient 5% of all cars. And guess what the first thing we want to do is? Sketch a picture. Again, there's my 24, and 30 is about one standard deviation. We're the top 5%, so it's a small group over here. Sketch it, and it's all that above. Now, before we do the table, we don't want to use 5%. The most efficient 5% is this part. That's 5%. But remember, we shaded to the right. So when we actually graph it, or not graph it, but when we actually do our calculations, when we look at our table, we want to find the percentage to the left. So we're actually looking for right there the 95th percentile. So when we do the calculations, we're not using 5%. If you used 5%, you should know there's a mistake when you're all done. Because when you're done, you're going to get a negative value. You'll get a negative z-score, which should tip you off. But you're also going to get a very small X value. You're going to get a gas mileage that's below the mean, and you're going to say, oh, that doesn't make sense. So 95% is 0.95, which when we look at the z table, gives us a 1.65. And because it's symmetric, a 5% would just be a negative 1.65. So if you do pick the wrong one and you see that that's negative, all you have to do is get rid of it, really. So 1.65 equals x minus 24 over 6. Again, we just keep doing the same process over and over. I'm going to multiply by 6 and then add 24, and I get x equals 33.9 miles per gallon. And we're ready to write it up. According to the normal model, we would expect the most efficient 5% of all cars to get at least 33.9 miles per gallon. Okay, we're just about done with this example. What gas mileage would you consider unusual? This is up to you. If you can explain your choice properly, you're going to be okay. Some people would say 2 standard deviations. Some would say 3. If you're 2 standard deviations away, only 5% of all vehicles will have gas mileages outside of your range. If you do 3 standard deviations, then only about 0.3, or on each tail, about 0.15 or 1.5% will be outside of it. So 2 standard deviations is unusual, 3 is even more so. So however you explain is fine. I'm going to go with 3. I would accept if you said 2 as well, as long as you explain it properly. So anything more than 3 standard deviations from the mean is very unusual. I would expect gas mileage below 6 miles per gallon, because that's 3 standard deviations away. Or above 42 miles per gallon to be very unusual.